Hey everyone, for a while I've been wanting to add automation to my exoskeleton, and I finally had some success with it. This video is about how I automated the exoskeleton, and I'm still working on it, of course. And these experiments are with the arms, but what I'd like to do ultimately is automate the legs so that I can have a walk mode, a run mode, a stair climbing mode, etc., where I just push a button and all of those modes will activate and the exoskeleton will do what I need it to do. Alright everyone, this is how I automate the exoskeleton. This automation module I built is based on an Arduino Mega 2560 R3 microcontroller right here. And it has two relay boards. Each one has 8 relay modules to it. So each group of 2 modules goes to one cylinder. So I have the tricep, bicep, and the shoulders. And then I have 2 extras. These 2 will work for the chest armor. And then on this side I'll just have 2 left over if I want to use it for something else. And this is not the first automation unit that I built. The first one was smaller and I actually burned out part of it, but it was a very good learning experience, and this one works much better. If you want to see the troubleshooting that I went through on the first automation module, I have a video for that. One other thing I have is this screw terminal shield. Basically the way it works is the wires that connect the microcontroller to the relays, you just plug them into these ports and they could slide in and out, so they could actually slip out. But with this screw terminal shield, it has these pins which actually plug into these sockets, and then I could put the wires in and screw them into place if I want to, so it's much more secure. But I'm not going to use this for now for this first experiment because I actually like the way it looks without it, but I'll probably put it on afterward just for more security. Okay, ladies and gentlemen, exoskeleton enthusiasts, I have the new automation module installed on the back, and it's so much cleaner than the old one. This was the old one right here, and if you saw any of my previous videos, you'd know that it had these cables connected to it which lead to the front of the arms, and those are still there. I'm going to deal with those later, but for now it's clean. These relays are all wired up to their own respective solenoid. Maybe I could shorten these wires, but that's okay for now. And let me plug it in, and what we're going to do now is a test, because each relay corresponds to a different cylinder, hydraulic cylinder, for a different range of motion. Now let me plug it in. I have my laptop right here, and I'm going to use this cable to power it up. I already uploaded the software to run through each solenoid, and you can see that the lights are coming on and clicking in sequence. That's the right arm. Now here's the left arm, left tricep. Now it's on the bicep. Bicep up, bicep down, left shoulder to the right, left shoulder to the left. Very good. And now it's just running through the sequence to make sure it's all wired correctly. Now I'm going to attach power, 12 volt power, to activate the solenoids, and let's see what happens. Now you can hear the solenoids, and you see the lights on the solenoids over to this side are coming on to match the lights on the relays. So that's exactly what I want. Each arm currently has 3 degrees of freedom, which means that it has 3 joints and can articulate at those 3 joints. Currently it's the tricep, which is the upper arm, moving the arm up, the bicep, and the shoulder. I'm going to eventually add cylinders for the wrists, so the wrists could flex up and down like this, so the wrist could roll like this, and then so the hand can grip. So all of that's coming in the future. So right now it's good. So what I could do right now is write a program to put the arms in a sequence of movements as a test, and turn on the hydraulic pump, and they should move. So I'm going to do that next. That was a practice run of the arm, doing some arm curls. I have the bar here, but I don't have the weight on it. And I see that the arm is not moving the full range of motion, so I'm going to adjust the amount of time that the relay and thereby the solenoid is activated so that it'll extend down further and then get it to rise up in the full range of motion. So I'm going to adjust that in the code, and then I'll run another test. Okay, I've successfully integrated the automation circuit, and I've uploaded a code for the left arm. Just for fun, I'm going to turn on the light, and I'm going to turn on the hydraulic pump, which is kind of loud, but it's not the permanent one, it's just for test purposes. And then I'll plug the microcontroller into my laptop to power it up, and we should see the arm cycle through its programming. Going with 280 pounds or 127 kilos, which might be a bit heavy for a first weighted test, but I once heard it said that sometimes you have to run before you can walk. Okay everyone, I've successfully integrated the automation. Alright, I've successfully integrated the automation circuitry. That was a rough test. It's really wobbly because it's just hanging from chains, but it passed the test. It did work. Some things have to be fixed up, but it's a learning experience. So now the question is, did I build the world's strongest humanoid robot? Okay everyone, in that last clip of a failed test where it tripped the breaker and the lights went out, what I think happened was one of the wires from the microcontroller came loose from the relay modules, either the 5-volt wire or the ground wire. And there's one of each going into each relay module. And if they're not connected, then the microcontroller can't control the relays properly. So as far as I could tell, one wire came loose and it caused the relays to just malfunction, just not work properly. And one of them was activated and it just stayed activated, and it was sending hydraulic fluid. It was activating a solenoid, sending hydraulic fluid to a cylinder that, as far as I could tell, was already fully maxed out and locked out. So it was just causing the motor to try to keep turning the pump as hard as it could. And I was looking at the gauge on the power unit, and it was just like rising up and bouncing off 2500 psi, which is where I set the pressure relief valve. And working so hard, the motor just was drawing too much current and it tripped the breaker. So that's what happened. Something that I definitely learned is that I do not like the pin system for attaching the wires. If you see this wire right here, it's a jumper wire which connects the microcontroller to the relay module, and on the relay module there are these pins. Hopefully you can see them right there, and the ends of the wires there's a female end, a female socket, and it slides onto the pin like that to make the connection. And it's so loose, like after a while it just, look at that, after a while it just gets loose and it'll come out with the slightest bit of vibration. And that was giving me a lot of trouble during this experimentation. On the microcontroller it's not as bad, it's the opposite. The pins, the wires have a male end, and then the microcontroller has, and see how easily that just came out? The microcontroller has the sockets. So it's a little bit better. Maybe it's about manufacturing quality or something. But I'm definitely going to put that screw shield on here so that I could use set screws to hold the wires in place on the microcontroller. I would like to find something to put on these pins here so that I could have set screws for those wires also. Because if I'm using the exoskeleton doing search and rescue or fighting supervillains and these jumper wires are coming loose, that's going to be a major problem. I can't tell a supervillain, hold on, I got a loose wire, let's pause the fight for a minute. That's definitely not going to work. Well, anyways, thanks for watching. I hope you always find something to look forward to, and I'll see you in the future.